Hello today. If it's all right, I'm going to do some more maths with you today, if that's all right. Sort of percentage sums and stuff like that. So I want to just show you this actually. And on this side, I want to show you that. Yeah, I've written the word 50 because so that you know that if my 50 wasn't clear, I've written it in word form. I just wanted you to see that. Thank you. Lovely, thank you. So I just wanted you to see that. Thank you. Um, Lovely, thank you. And I'll just um, do some more sums if that's all right. Right. I just want to. Right, I'm going to write something else down as well. Um, right, just. Sorry, I'm just writing some sums out at the moment. I've just written some. Sorry. Thank you for being patient. I've just done this here. Just thought. Thank you for looking at that. And the answer is 15, 25, 7.5, 7.5, 3.75 and 3.75. So I just wanted to show you that. Thank you very much. Thank you. Just wanted to show you that. And some of the questions are different, but the answers are the same. So I just thought I'd like you to look at that. Thank you for looking at that. Lovely. Thank you. Just wanted you to see that. Yeah, thank you very much for looking at that. Right, thank you. If I just do this as well, it might, a little thing I might just do for you here. Just wanted you to see that. Thank you. Thanks for looking at that. Thank you. Just wanted you to see that. Thank you for looking at that. Thanks. I also want to write something else down today. Thank you for watching what I'm doing, or what I eventually try and achieve with my sums and stuff. So I just want to write this down. I just want you to see that as well. Thank you. Thank you very much. Thank you very much. Thanks. And the other time I wrote out the speed of light per second in miles. It's 186,282 mph, and the speed of light in an hour is I think it's that, because what I do is I times that 186,282 times it by 60 to get it into a minute, and then times it by 60 again to get it into the hour. And so I think it's that there. I know sometimes I've come up with other answers for the speed of light, and that might be more exact and precise, and the other one may have been approximate. They're such big, powerful figures. It's very hard to sometimes get it right, and there's always seems to be a bit of a range actually. So I just wanted to see that's an MPH there. Yeah, just thought I'd see that. Tell you that. And also I was doing a long division question, some on the maths part 3, and so if I do this. Right, that comes to 7.5. Just want you to see that. But if I do this to make sure that I'm right, I want to know that I'm right. So I want a twit-proof, foolproof method to avoid being wrong. So I just do this. 880 times 7.5 to know that I'm right. And if I do that, 880 times 7.5 gives you 6,600. So gives you 6,600. I've cheated a bit. I haven't done them along multiplication, but that is right. So I just wanted you to see that. Thank you. Thanks. And that again, just want you to see that. Thank you. Thanks very much for looking. Thanks. Lovely. So that is that's 6.7. That's the speed of light. 670, 615, 200 mph is the speed of light. 670, 615, 200. 670, 670, 615, 200 mph is the speed of light in mph. So I just want you to see that. Thank you for that. Right. And the other time we were talking about the spinning on its axes, weren't we? Which is, for day-night, and that's 1,000 round the equator, isn't it? And round latitude 51 or 52, it would be about 600, maybe under 600 for us to go to spin on our axes for day-night. And from January the 1st of say 2020 to January the 1st of 2021, we'll have travelled 416,000 miles. So we'll have done that figure. And if you divide that by 365 and then you divide it by 24, you get it's 66,600 mph. So I just wanted to share that with you. That's right. So I just wanted to write that down. So I just want you to look at that, if that's all right. Thank you. All this is for your benefit. What I'm doing is I'm trying to help. I'm trying to make stuff that perhaps you thought was complicated. I'm trying to simplify. So if I just quickly put in 583. 416. Divide that by 365 by 24. Yeah, it's about 66,600 miles an hour that as we orbit the sun. From the 1st of January, to the 31st of December or the 1st of January the following year. that's what we've covered. So that's the speed that's the mph that planet Earth moves at. And we've covered the distance of 583,416,000 miles and that's every year. So I just wanted to say that to you. Thank you very much. Thank you. Thanks. And I just want to another thing I want to just write down here is this. Doesn't Right, I just want to show you that, what I've done there. Thanks, thank you for looking at that. Well, thank you very much for looking at that. Now, you can actually, there are ways of coming to there are different ways, different calculations to come to the same answer. So, different ways of doing something, but the answer is identical. So, on the top one there, just want to show you that. Right, on the top one, if I take the 100, I'm doing the diagonals here. If I take one naught off the 100, it gives me 10. And if I take the 1760 naught off, so then you've got that like that. So if there are two noughts, you can cancel two noughts diagonally. But what you can't do, you can't take one naught and then not take off the other naught. So basically, that's right. So you can do two. You can do, if there are two noughts on the diagonals, you can take two noughts off the diagonals, and if there's only one naught, you can take one naught off the diagonals. So if I do it that way, I'm just 660 times 10 is 6600, right? So 660 times 10, the top bit is 6600, and if you divide that by 176. And then you just divide it by 176. And you get your 37.5. So that's the first stage. If I put that's the first stage, and then that's the second stage. Okay, so the first stage is at the top, the second stage is lower down. I just wanted you to see that. Thank you. Thank you very much. And again, it's exactly would work the same way for the other one, for the one at the bottom there. If I took the two, because there are, well, with that one there's 1760 and there's 100, but you can only take one naught off the 100 at the bottom. You can't take two noughts off. But it's the same. So you take one naught off the diagonals. So I just thought I'd show that to you. So you take one naught off the 1760, so it's 176, and it's 10 there. Instead of it being 1760 and 100. So anyway, I just wanted you to see that. Thank you very much. Thank you. Thanks. And another thing I want to just look at today, very quickly, I want to just do some area with you, actually, if that's all right. We can just quickly do some areas. Yeah, I'd like to just do... If I just do this here, so I'm going to just write this out. Right, I just want you to see this. Thank you. And this is area. I'm not doing I could do the perimeter, but I'm just going to concentrate on the area actually with you, if that's all right. Now, the it's all got to add up. You know, all got to be exact and precise here. So, if you look at this line here, where the 8 is, where the 8 is, it's on the down bit. It's 8 centimeters, right? So the units are centimeters, but I've put the centimeter on one of them, but or a couple of them there. Now, it's got to add up on the other side. So it's 5 and 3 on the other side. On the other side, where you can on the opposite side of the 8, it's 5 and 3. So that gives you 8. So it's actually all got to add up, you know, and be exact and precise. And then the 9 there, where the 9 is at the top, you've got 5 there, and then you've got 4. So that's and they've got to add up. You know, they've got to correspond and be exactly the same. If you know what I mean. So yeah, the 5 and 4 they add up to 9. So the other bits have to add up to 8, and the other bits have to add up to 9. I just wanted you to see that. So I just thank you for looking at that. I'm just going to do one more here. If I just do this here. The units are centimetres, so I just thought I'd say that to you, but I just want to show you this here. Yeah, I just want you to see this. And again, it's quite self-explanatory, really. You know, obviously, I don't always know what level to pitch this at, but I know sometimes I used to struggle with this when I was, when I was younger. I used to struggle with this a bit. But I think if someone shows you good examples, I think you can sort of overcome your struggles, if you like. Anyway, so I just wanted you to see that. Yeah, there's a 12 at the bottom, so it's 8 and 4 correspond with that, so it has to add up to 12 at the top. And on this side where there's the 8 on this side here, you've got 5 and 3, so that has to add up to exactly the same. Anyway, I just wanted you to see that, and perhaps, you know, area people won't be so frightened of area because, you know, you just need to find some good examples. Anyway, thank you for that. And I just quickly want to there's a couple more things I want to do. Just see. Oh yes, I was saying from the other time, if a professional athlete runs 10 seconds he runs 100 meters in 10 seconds. So he's done 100 meters in equals 10 seconds. He will then have done, to find this speed in mph or kilometres, let's say, maybe kilometres, he'll have done 600 metres. If he kept it up, he'll have done 600 metres in a minute. And then 600 times 60 gives you 36,000 kilometres, 36,000 metres, sorry. 36,000 metres, and then you just knock off to find out what he's done in kilometres. It's just not 1,000 metres equals a 36. There are 1,000 metres in 1 kilometre, so it's 36 kilometres per hour he'll have travelled, or he or she, or whatever. Anyway, so I just wanted to show you that. Yeah, 36 kilometres per. So if he's done 100. If he's done 10 seconds, 100 metres in 10 seconds. It's actually 36 kilometres per hour. So I just wanted you to see that. Thank you for that. Thanks. And one more thing I want to do today. Couple more things, and then I'll wrap things up with you. I would like just to just do another thing with you. Yeah. So 1% of 8, let's say 1% of £8, let's say. And then I'm going to put 1% of £80. So if we just look at that, 1% of £8 is 8 pence, is 8p. And 1% of 80, 1% of 80 gives you, I think it's 80p, 80 pence. So, and again, if you want a foolproof method to see that you're right, I'll just do that, show you that. Thanks, thank you for looking at that. If you want a foolproof method, to know that it's a sound method to know that you're right. You've got your answers there. So 1% of £8 is 8p, and 1% of £80 is 80 pence. So what you just do is you say, if I said 100 times 0.8, so 100 times 0.08 gives you £8, or 8, just the number 8. And if I said 100 times 80p, that'll be 80. So 100 times 80. Yeah. So I just wanted to, sort of try and explain that to you. So 8p and 80 pence down at the bottom there. But anyway, I just wanted you to see that. Thank you. And then if you wanted to find out what the 2% was, you just keep adding the 8p or the 80p, depending on which question you're looking at. So if it was the 1% of £80 or whatever, it would be 2% would be £1.60. So 2% of 80, yes, is 160. You just keep adding it up. 2% is 160. You just keep adding the 8p or the, so for the 2% of 8 would be 16p. That's just a 2% of 8. Yeah, it's 16p. So you just do that. Thank you for looking at that. Lovely, thank you. And another thing I just want to say today, I think one more thing I just want to say to you is something that I just want to say this to you. Right, I just want to quickly talk about infrasound and ultrasound here. Infrasound is covering sounds beneath or below 20 hertz. So I just wanted to say that to you. So it's 20 hertz. Sorry. So infrasound is covering sounds beneath or below 20 hertz. That's what infrasound is. Thank you for looking at that. Infrasound. Sound waves with frequencies below sound waves with frequencies below 20 hertz. And so the human frequency is its range is from 20 hertz to 20,000 hertz. So it's 20 hertz to the range is 20 hertz to 20,000 hertz. Or if you want to put 20 kilohertz. So I just different. So I just wanted to show you that. Thank you. Thanks very much. I just wanted to say that to you. And the ultrasound is the ultrasound frequency is higher than the upper limit of human hearing. So it's the ultrasound starts at 20,000 hertz. Ultrasound starts at 20,000 hertz. And infrasound is below 20 hertz. So I just wanted to say that to you. And ultrasound devices operate with frequencies. So that's right. Ultrasound devices operate with frequencies from 20 kilohertz onwards. And there's medical, isn't there, and diagnostic and medical, and yeah. So again, it's from 20,000 kilohertz. The ultrasound starts, and that's the higher one. Infrasound is the lower one, and ultrasound is the higher one. And it's from 20,000 kilohertz. And the range is vast. It goes up to gigahertz. Just thought I'd tell you that. And it also includes 200 megahertz. And I think that's right. And I think the megahertz is used for medical for some imaging because it's not as dangerous as radiation. Echoes and sonography. Yeah. I just wanted to say that to you. So ultrasound is for is the ultrasound frequency is higher than upper limits of human hearing. Higher than the upper limit of human hearing, and infrasound, as we've already said, covers sounds beneath 20 hertz. So sound waves with frequencies below 20 hertz. The lower part, the lower limit of audibility is infrasound, and the higher higher limit of human hearing is it starts at 20,000 hertz, or 20,000 hertz, or 20 kilohertz. Is this starting point for the ultrasound, and as I said, its range is massive. It goes to gigahertz, and it includes gigahertz, and it includes megahertz, 2 to 200 megahertz, I think, and I think it's the megahertz is used for the medical side of it. To image the body, echoes, and the sonography, and because radiation is dangerous. So anyway, I just thought I'd say that to you. Thank you for listening to me today, and if you like what I'm talking about, could you subscribe to my channel, please? Thank you very much. Thank you for listening to me. Thank you. Bye.